Hello students. Welcome to our 11th physics class. This video continue with first lesson, Nature of Physical World and Measurement. Today we have learned about 1.4.5 SI unit of system. SI means System International. SI unit system, the system of units used by scientists and engineers around the world is commonly called the metric system, but since 1960 it has been known officially as the international system. The international system of metric units, the SI and observation of system internationally are international system or metric system of measurements. It is an internationally standard system giving a common language between nations and between the different branches of science and technology. The SI with a standard scheme of symbols, units and observations were developed and recommended by a general conference and weight and measures in 1971 for international usage in scientific, technical, industrial and commercial work. And the 7 SI base units, which are comprised of length, mass, time, amount of substance, electric current, temperature and luminous intensity. The unit of length is meter, the unit of mass is kilogram, the unit of time is second, the unit of amount of substance mole, the unit of electric current ampere and the unit of temperature Kelvin, and last one, the unit of luminous intensity is candela. The advantages of the SI systems are: first one, the system makes use of only one unit for one physical quantity, which means a rational systems of units. And second one, in this system all the derived units can be easily obtained from basics and supplementary units, which means it is a concurrent systems of unit. It is a metric system, which means that multiplies and submultiplies can be expressed as power of 10. Why is SI units important? Why is the SI systems a rational systems of units? And why is the SI systems a concurrent systems of units? The SI units is an international systems of measurement that are used universally in technical and scientific research to avoid the confusion with the units. Having a standard unit system is important because it helps the entire world to understand the measurements in one set of unit system. Why is the SI systems a rational systems of unit? When a people were first developing systems of units, they used things like the length of the king's foot that made perfect sense at the time. So separate systems were developed for measuring everything that we needed to measure. Then science got a role and we found that we got two things that used a lot of different measurements, but it was a mess. None of the units worked well with other units. Then the French and others got together to design a systems that used two various units constantly. In the end, we got the SI systems where each unit is designed to play nicely with all of the other units. If you are just using length of instance, then the SI systems is not much better than the old ones. But as soon as you are using several units, length, area, pressure and strength, then the SI system is hardly better. So almost all engineers and scientists use SI. And the SI system is based on all units being factors of 10. It has meters, decimeters, hectometers, kilometers for 1, 10, 100 and 1000 meters. Going the other directions, meters, decimeters, centimeters and millimeters is 1, 0.1 and 0.01 and 0.001 meters. All units in the SI systems use these common methods of expressing difference in size. A congruent derived unit is defined as a derived unit that for a given system of quantities and for a chosen set of base units is a product of powers of base units with no other proportionality factor than 1. The International Systems of Unit 1960 was designed around the systems of concurrence. In SI, there are 7 fundamental units as given, and first one, length. The unit of length is meter and its symbol small m. And scientific definition, 1 meter is the length of the path travelled by light in vacuum in 1 divided by 299,792,458 of a second. 1983. What is 1 meter? Let's define 1 meter distance repeated to a light. Before the define this length, it is should know what distance light travelled in 1 second in vacuum. Light exactly travel 299,792,458 meters of the distance in 1 second. So, the mathematically, if light traveled 299,792,458 in 1 second. So, at what time light travel exactly 1 meter distance? T equal to 1 upon 299,792,458. This will be time taken by light to travel exactly 1 meter distance. And it is correct definition is the meter is length of the path travelled by light in vacuum during a time interval of 1 upon 299,792,458 of a second. And second base quantity mass and its unit kilogram and its symbol small k and small g. Its correct definition, 1 kilogram is the mass of the prototype cylinder, a platinum iridium alloy preserved at the International Bureau of Weights and measured at Servers near Paris, France, 1901. The cylinder is can see here. It is made up platinum iridium alloys. It is only prototype of 1 kg. The international 1 kg standard of mass, a platinum iridium 9:1 cylinder 3.9 centimeter in height and diameter. Why is the cylinder used in defining kilogram made up of platinum iridium alloys? That means this is because the platinum iridium alloys is least affected by environment and time. And third fundamental basic quantity is time. The unit of time is second. Its symbol small s. And definition, 1 second is the duration of 9,192,631,770 period of radiation corresponding to the radiation transition between the two hyperpine levels of the ground state of cesium 133 atoms in 1967. What is 1 second? This is cesium atoms and it has 1 electron. It is outermost orbit. Now, when this electron and oscillate between two hyperpine levels, we always get waves whenever theory has oscillation. Now, These waves has some characteristics. The basic characteristic, the time period of waves, that is time to complete one waves in called one period. If these waves cover exactly 9192631770. The definition is technically is given by the second is the duration of 9192631770 periods of radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-133 atoms. Fourth fundamental basic quantity is electric current. The unit of electric current is ampere. Its symbol capital A. Its correct definition: 1 ampere is the constant current which, when maintained in each of the two straight parallel conductors of infinite length and negligible cross sections held 1 meter apart in vacuum, shall produce a force per unit length of 2 into 10 to power of minus 7 Newton per meter between them in 1948. What is the definition of 1 ampere current and right hand thumb rule? It is fundamental quantity which respected to the current flowing in conductors as force excited between them. Let's first understand what is actually happen this conductor when the current flow through it. Before that, these assumptions, the conductor which is considered should have minimum cross section area and it should be infinitely long, particularly should be long conductor. Already speaking, see this conductor, when current flows through it, this acts the magnetic field in this direction which is given by right hand thumb rule. If your thumb the point towards the flow of current, then the fingers, the direction of fingers will show you the direction of magnetic field is perpendicular to the plane of the paper. Current in both the wire are in the same direction, attracts each other, and two parallel conductors carrying current in same direction experience an attractive force. Thus, the force experienced by two parallel current carrying conductor is attractive if the direction of electric current passing through them. So, its definition as 1 ampere. 1 ampere is defined as that current when it is passed through each of the two infinitely long parallel straight conductors kept at a distance of 1 meter apart in vacuum, causes each conductor to experience a force of 2 into 10 to power of minus 7 Newton per meter length of the conductor. And the fifth fundamental basic quantity is temperature. The unit of temperature is Kelvin. Its symbol capital K. And its definition: 1 Kelvin is the fraction of 1 divided by 273.16 of the thermodynamic temperature of the triple point of the water. You must know phase of water, absolute zero temperature and triple point. First off, what is the phase of water? Under normal condition, the water exits in one of the three phases: the solid phase, that means ice; the liquid phase, that means water; and third one, the gaseous phase, and it's steam. And liquid water is an amazing substance. And what is the triple point of water? The triple point water of 0.01 degree Celsius. The ice is below 0 degree Celsius and water is 0 to 100 degree Celsius and vapor, that means gaseous state, is above 100 degrees Celsius. Absolute zero is the point at which the fundamental particles of nature have minimum vibrational motions, retaining only quantum mechanics 0 points energy, induce particle motion. What is triple point? Consider the temperature and pressure from water. Water is 3 stage in, that is solid, liquid and gases. It is 3 curve for it, but note down one point where all 3 curve for it. That means at this point pressure and temperature we will get 3 quantity. We are 3 spaces and this point is called triple point. And why is it called a triple points? In thermodynamics, the triple points of a substance is the temperature and pressure at which the 3 spaces gas, liquid and solid of that substance coexist in thermodynamics equilibrium. It is that temperature and pressure at which the substance curve, fusion curve and the vaporization curve at mid. The triple point pressure is 610 Pascal and the triple point temperature is 0.01 degree Celsius. Its Kelvin's level 273.16 Kelvin, which is converted to Kelvin 273.16 Kelvin divided by 273.16. Then we'll be getting 1 Kelvin. Yes, this is definition of 1 Kelvin. The Kelvin is the fraction of 1 divided by 273.16 of the thermodynamic temperature of the triple point of water in 1971. Sixth one, amount of substance. The unit of amount of substance is mole, is short term MOL. Its definition: 1 mole is the amount of substance which contains many elementary entities as they are atom in 0.012 kg of pure carbon 12 in 1971. What is amount of substance or 1 mole? When easily count the number of marbles because visible to us. But what about microscopic element and like atoms and molecules? Yes, very difficult count them because we cannot see them our eyes. That is, in sphere physics is introduced new set of unit that is called mole. Consider many number of atoms as in 0.012 kg of carbon 12 element. The number of atoms in 0.012 kg of carbon 12 are considered as a benchmark. Define 1 mole. It's defined as the mole is the amount of a substance of a system which containing as many elementary entities as they are atom in 0.012 kg of carbon 12. How much amount of atom in 0.01 kg of carbon 12 have? Yes, it has exactly the amount of Avogadro number Na equal to 6.022 into 10 power plus 23. 1 mole of hydrogen atomic mass weight 1 gram. 1 mole of oxygen atomic mass weight 16 gram. 1 mole of chlorine atomic mass weight 35.5 gram. All these scales show the masses of same number of atoms as in the 1 mole of carbon 12. Na equal to 6.022 into 10 to power of 23, that is Avogadro number. Last fundamental base quantities is luminous intensity. The unit of luminous intensity is candela, is short symbol small c and small d. Its definition: one candela is the luminous intensity in a given direction of a source that emit monochromatic radiation of frequency 5.4 into 10 to power of plus 14 Hz and that has a radiant intensity of 1 divided by 683 watt per steradian in that direction in 1979. What is one candela or luminous intensity? In these sections, I explain your luminous intensity, the different source of light and different colors of light among them, the most common similar color red, orange, green, blue and violet. These different colors have different frequency and wavelength. For example, red is 435 to 495 terahertz. Tera means 1 terahertz equal to 10 to power of 12 hertz. That means 1 lakh crores hertz. Consider a monochromatic light means monostain. One chromatic means colors, that is a single colors light or single frequency of source or single wavelength of source. Consider a frequency of 540 into 10 to power of plus 12 hertz and area which is covered by light. That substance the solid angle of exactly 1 steradian. The ratio R equal to 1 and A equal to 1. When this area is 1 upon 683 watt as radian, intensity of exactly upon 683 watts, radian intensity of power, that is energy per time. When this area has radian intensity of exactly this value, the luminous intensity of light is called 1 candela. The definition is given by: the candela is the luminous intensity in a given direction of a source that emit monochromatic radiation of frequency is 540 into 10 power of 12 Hz or 5.40 into 10 to power of plus 14 Hz that has a radiant intensity in the direction of 1 upon 683 watt per steradian in 1979. Today portions over. Then homeworks. The 7 fundamental basic quantities read and write 2 times. Thank you students.